Software. It runs the world. E-commerce, payments, fraud detection, trading platforms, IoT, business software, digital transformation. And if you're in business, building all of that software falls to you every day, 24/7. So, you hire teams of developers and build systems to support them. Why? It's the future of your business. Not surprisingly, you've embraced the cloud, and you rely on Java. But there are challenges. How do you adapt to security threats, upgrades, infrastructure costs? And then there's the massive scale and blazing performance demands of big data, machine learning, analytics, and search. So, with all that, and because you've bet on Java to build mission-critical apps, and because you're running those apps in hybrid multi-cloud infrastructures, you need more than the standard Java codebase. You need a Java platform. A platform that delivers analytics, optimization, scale, and performance, but also reduces infrastructure costs by up to 50%. A platform built on the OpenJDK standard and trusted by the leaders in global business. A platform that is 100% compatible with your apps, but also 90% less expensive. Azul is the platform for the modern cloud enterprise, giving you more value, more security, more performance, and more of the Java you love so you can propel your business forward. Azul, the Java platform for the modern cloud enterprise.
In this talk, we'll look at the current state of Pi4J and dive into the code of a few examples. We'll experiment with Java on a Pi, a Raspberry Pi-based laptop, to interact with electronic components. Here with us is a Java champion, developer, and author of Getting Started with Java on the Raspberry Pi, co-organizer of BJU, and contributor to Pi4J. Let's all give a warm welcome to Azul Senior Technical Writer, Mr. Frank Delporte.
Wow, that's quite an introduction. Thanks for that. Let me share my screen. Okay, welcome to this session. Indeed, I'm going to talk about Java and electronics and what I learned in my journey with experimenting with these both things on a Raspberry Pi, and maybe I hope I can learn you some stuff about this really wonderful combination, a combination that allows you to experiment. The goal of this presentation is at the end that I will invite you all to join my Pi, which is a little device I will show you later. and control these components like you see here on the screen. And I have my little friend here behind me will be able to show that and see how that behaves. I see I'll have to. Okay. My journey started a long time ago with this Commodore 64. I guess you can guess my age based on this computer. That was my first computer when I was 10 or 11 years old. And it was a real fun experience already at that time because we were even having LAN parties before networks existed. And also based on this clothing the clothes that we were wearing, you can estimate a bit the time this was happening. Now, I find that this Commodore 64, although it's very old, at that time was already better than the computer that I'm using nowadays, Apple. And why is that? Because of, maybe you noticed on the picture, there are some electronics around that computer. So I was able to hijack the joystick ports to read button presses, for instance. But I could also connect something on the back of the computer to control electronics. And with a relay board, I was able to control my Lego trains. So at that time already, it was possible to combine software and hardware electronics to have very nice projects like controlling my Lego trains, or I had a disco bar, I was controlling lights. All that kind of stuff was already possible many years ago with the Commodore 64. Now, I went through a whole journey of film school even, and I started doing web development when the internet was born. And more than a year and a half ago, I joined Azul, which is an OpenJDK distributor, also offering Java support. And you may know us from Azul Zulu, which is one of the many runtimes you can use nowadays, an OpenJDK distribution. And what is a bit a coincidence, I was already experimenting with the Raspberry Pi, is that Zulu is one of the very few runtimes that you can find even for the very first initial Raspberry Pi boards with an ARM v6 processor. So there is Java available for all the different Raspberry Pi boards and a lot of other platforms, of course. Azul also has Platform Prime, which is another OpenJDK distribution. Actually, it's you can consider it a fork. There is some more in there that is not in the traditional OpenJDK. And the main goal of Prime is to give you a lot of performance improvements without the requirement to change your code. Crack is another project by Azul, and it's a project that aims to speed up the warm-up of your application and also the start of your application. And we have done some experiments with that. And when you're using a cracked Java application, you can gain a lot of startup performance time. So, for instance, Spring Boot, that test that we have done, went from 4 seconds to 40 milliseconds. And that was a fun project because I also wanted to do that on a Raspberry Pi. I'm not going to dive into this in this presentation, but if you want to know more about it, you can find it on my website, webtechie.be, where I have been experimenting with Crack on a Raspberry Pi to see if I indeed could also speed up the start of a Java application on the Raspberry Pi. I'm in the process of improving this and retesting this, and you will find new blogs on my website. You can also find a lot of my content on Pi4J. If there's one website I want you to remember from this presentation, it's pi4j.io. It's a website for the friends of OpenJDK. I think we are all friends of OpenJDK. So I invite you to visit this website. You will find at least one article a day about a topic related to Java, OpenJDK, Kotlin, tools, best practices as a developer. So a lot of information that you can find here. My content is also on there, so if you're interested in running or experimenting with Java on the Raspberry Pi, there are a lot of examples here that you can immediately use with source code and all included. I'm also the host and producer of the Pi4J podcast, so a few times per month we have a new podcast about a Java topic, so please be invited to check out 4j.io for all this great content. Now back to the main topic of this presentation, and that's the Raspberry Pi, which is the core of what we'll be exploring. The Raspberry Pi exists in different models. The most well-known is the B version, which has a lot of connectors, USB network, several displays. The latest boards have two HDMI connections, and they are available in different price ranges. Now, please watch out if you want to buy a Raspberry Pi. What you see here on the screen are the official prices, I think in Europe mainly, but they should not be that different across the world. Because of the chip shortage, there were a lot of sellers who were using other platforms to sell Raspberry Pis at much higher prices. Those were not official resellers, so only the official resellers will sell Raspberry Pi at these prices. But as you can see, the Raspberry Pi Zero, like for instance the 15 euro edition, has a quad-core processor, and you can run Java, JavaFX, all the applications that you're used to build can run on a Raspberry Pi. So it's an ideal device for testing and running applications on different platforms if you want to do some experiments. Last month, the Raspberry Pi 5 was announced, and 2 days ago, 23rd of October, the first ones were sold also in the Raspberry Pi store in the UK. And now in the next weeks, the first deliveries will happen for people who pre-ordered such a Raspberry Pi. Now, if you look at this picture, that's the first edition and the 5th edition of the Raspberry Pi. It's still the same size, form factor, but there are, of course, a lot of evolutions. There's 11 years between the first one and the 5th one, and it's really a really powerful device if you want to run Java and any other type of application. You may have seen on the overview page that there is also a compute module. The idea of the compute module is if you need a computer in any type of product that you're building, that you can buy the compute module and add it to a baseboard that you develop yourself, or there are, of course, different ones available. But then you can build really the computer with the connections you need for your project. I think they are used inside washing machines or any kind of device, routers, NAS devices. They use this kind of compute module to add a computer to any type of product. The Raspberry Pi 4 has also been used to form the Raspberry Pi 400. And what you see here is actually a keyboard with the Raspberry Pi inside. So this is a full computer. You only need to attach a power supply, a mouse, and a monitor, but you can get started. So everything is here. You can pop in an SD card in the back, and this is a full running computer that you can take with you anywhere you want, and you have a desktop screen available. Now, this Raspberry Pi 400, that reminds me a lot about of my first computer, the Commodore 64. It's a bit different in size, but it's the same kind of experience. You have a full computer that allows you to experiment, that is cheap, but still has a lot of power. What I'll not be talking about today is the Raspberry Pi Pico. You may have seen also this board. You should compare it to to an Arduino or an ESP32. So it's a microcontroller. This doesn't run Linux or any other operating system. So it's a different kind of usage. And that's not something that will run Java. For now, maybe one day, who knows. So the Raspberry Pi that I'll be talking about is a single board computer. You can run Linux on it. It's either the server or the desktop edition. So that means that you can just run it in terminal mode if you need it as a server, for instance, or a desktop with Ubuntu or Raspberry Pi operating system. So there are different operating systems available in 32 and 64-bit editions. And there was a problem with out of stock and higher prices, but actually that got a bit settled now, I think. Because if you check rpilocator.com, this is a screenshot, but let's look at the real website nowadays. You see that all these Raspberry Pis are now in stock. and I think there are several pages. So all the models, I think, are again available to buy at the normal listed prices here, which are the official prices because these are official resellers. If you're interested in how a computer like this is made, I invite you to check the video of Jeff Gerling. He creates a lot of content related to Raspberry Pis, tests also, sees what is possible, how far he can extend the functions of it. And this video shows you the Sony factory in England. So they are produced in England. And there's also some robots involved. There is some manual work to be done, and they make 3.1 every 3.1 seconds. They have a Raspberry Pi that's finished. So that's the number of Pi. So I think that's cannot be a coincidence. I think they tricked this a bit for the video, and that's Jeff showing the finished result. Now, what I learned about Raspberry Pi 5 is that they use some other components which avoid the need of robots, so they will be able to produce more of these Raspberry Pis and also faster. And what I specifically love about Raspberry Pi is the header. So there are 40 pins that allow you to connect any type of electronic component to this Raspberry Pi to be able to control it. Now, this header was actually not intended when they created the Raspberry Pi. So they wanted to create a computer which was cheap, affordable, usable for everyone. And the idea was, if you already have a television, you could connect it to your existing television and you didn't need a dedicated computer screen. And only when they were designing this very first Raspberry Pi, they found out that they had some pins left that could be used for, who knows, we will see. So they added this header, which was smaller at the time. I think it was 26 pins. And it turned out that that was actually the main factor, the critical thing to make this computer so popular, is that you can connect it to the outside world, like LEDs, buttons, components. I will show you a few examples. Now, 4 years ago, I had this crazy idea of creating this for my son, a drum boot controller. So you see there's a relay board again, a touchscreen. Can control LED strips. And because it's a Java application, of course, there's also an API. So we can call the API from anywhere in the house. So he knows he has to stop drumming. To be honest, this video is 4 years old. My son, I think he's twice the size he's in this video now. And because I already knew Java, but I didn't know electronics well, it was a long time ago, I was experimenting with electronics. I wanted to find out how I could do this with Java, build a JavaFX user interface and control the electronic components. So that led me to a journey of experimentation and trying stuff out. So for the next 6 months, this was on our dinner table. This was the fourth member of our family at that time. And I started with, for instance, this little small display you see here at the bottom, a 7-segment display, and found out how I could control that from software, from Java, from a Raspberry Pi, what wires are needed, and how do I, what are the possibilities of this component. And I started writing that down because it's always easier to find back later how you did things if you take notes of every step in your experiments. And eventually I ended with a book. So you can find it on my website, webtechie.be/books. It was also sold on paper, but that's sold out. And the ebook is available on Leanpub. And from time to time, I keep updating it. So if you buy it any given time, and there is a new version. You will receive an email to alert you that there is a new PDF available. And in this book, I went through the whole journey. How do I install Java? How do I install JavaFX? How can I use a database? How can I use message queues? All those things that we are used as a Java developer to build applications can also be used, of course, on the Raspberry Pi and allow you to interact with LED strips, with displays. Get the, like for instance, this little display here is showing the weather forecast. Now that's data retrieved from an API through Java and then shown on this LCD matrix display. And during this research, I also got into contact with Pi4J. And Pi4J is a library that you can find on pi4j.com. And it's a library, a friendly object-oriented I/O API for Java programmers to access the full I/O capabilities of the Raspberry Pi platform. That's really a mouthful and a lot of info. But the idea is that you can focus on implementing your application and you don't need to care a lot about how the electronics work. That's what the Pi4J library will do for you. You will be able to define a Java object, which is actually controlling a LED, for instance. And that's what I will show you. Now, how does this work? Within your application, you have a dependency that you define your POM file, which is the Pi4J library. Inside the library, some native libraries are packaged for both 32-bit and 64-bit systems. And it's actually this native code through JNI that will interact with the hardware interfaces. Like GPIO is just toggling something on and off, but there are also different ways to interact with electronic components like I2C, SPI, serial communication, PWM, that are all different types of controls for electronic components. And that's all available inside the library, handled through these native libraries, but it's something that you can call from your Java code and use from there on. So it's a very easy way to work with electronics, and to make it as easy as possible, we also extended the website. We'll come to that. A fun project is api.pi4j.com. Because we are in the Java world, the people involved in the Pi4j project are also Java developers, of course. So we want to experiment from time to time, so you can find a lot of different repositories within the Pi4j GitHub project, and api.pi4j.com is one of them. And actually, it exposes a website which gives you some history of the Raspberry Pi boards. So you have a list of all the boards. The Pi 5 will be added soon. With a picture, if available, then some information about the board, how many memory is there, what kind of chip is it, stuff like that. But maybe most importantly, these 40 pins, what can you do with them? And also, how do you need to address them? There are different numberings in use. It's now the BCM number that is important. But actually, so pin 1, 2, 3, 4, 5, 6, this is the physical order of the pins. But if you want to control them from software, the BCM number is the number that you will need to define in your Java code. And of course, because this is a Java project, it's using Spring. We can add an API and we can add a Swagger documentation page. So everything is well documented from the source. So we don't need to put a lot of effort in there. And all this data is, of course, available through the API as JSON. So if you want to know more about Raspberry Pi board or want to integrate it in some kind of project of your own, you can use this, or you can use a Java library, which is also available. And of course, because we're in Raspberry Pi space, we are hosting this on a Raspberry Pi. A Czech company, Finaltech, is offering us a Raspberry Pi for free, and this application, this api.pi4j.com, is running on a Raspberry Pi. So as I said, there's a website around this project, the Pi4J project. Now, I already told you about 4J, 4J.io. That's a website for everything related to OpenJDK. It's a starting point for all the information that you can find around Java. If you want to find information related to Java, JavaFX on the Raspberry Pi, then the Pi4J project can offer you a lot of information. So it's not only about controlling the electronics, it's also how to set up JavaFX, how to use JavaFX in kiosk mode. If you want to, for instance, create a terminal application with a touchscreen, you will find information there. How to run Java on the very first old Raspberry Pis, all that kind of information is available here on pi4j.com. I'm keeping an eye on the time. I want to show you a little bit of code for the minimal application. Like every developer that starts with a new programming language creates a Hello World application. Now, a Hello World application in electronics is blinking a LED. Can I control a LED from a software? That's the starting point in this kind of project. So you will find a project completely described like this on pi4j.com with the sources on GitHub. The sources contain both the Maven configuration and a Gradle configuration. So I myself am a Maven user, but if you prefer Gradle, you will find also the Gradle config in there. So you can choose which of both you're using. And it provides you with all the code. It's a very small part of code, but it provides you with the code to run a LED. And in this example, you see there's also a button, and this button is used to control the blinking speed of the LED. If you press the button, the LED will blink a bit faster, and after 5 times, the application will just stop. Now, just a little bit of code here is how you control a LED. In Java code with Pi4J. So first you have to define the address of the pin that you're using. So remember, this is the BCM number that I showed you before on api.pi4j.com. And it's actually the physical pin 15. If we go back to this drawing, you see here, this yellow wire goes to pin with a BCM number 22. We need the Pi4J context. So this context will load all the libraries that you provided in your POM file, which can be used by Pi4J to control electronics, like for example, the digital output provider. Digital output, that means that we will put the power on that pin between 0 and 3V3, which is the values used by the Raspberry Pi. So if it's low, false, then it's 0. If it's true or high, then it's 3.3 volts, and some IDs and addresses. So this is the address that we used before. And then we create a LED object. So this Java object, the LED Java object, is actually the Java code representing a physical LED. So if you interact with the Java object, you are interacting with the LED on the breadboard. So what we can do now is toggle this LED, just a while loop, and if it's high, then we make it low, and otherwise we make it high, and then we wait a little bit. So this will create a blinking LED. So this is all the code you need to define a LED and have it blinking. Now the application does a little bit more. As I said, it also uses the button to read the state of the button and make the blinking of the LED go faster. So this is a little video showing this. In the background, you see the screen of the Raspberry Pi. You have this blinking LED, and each time the button is pressed, the LED blinks a bit faster. And after 5 times, the application will stop. No rocket science, not at all. A very basic application, but it's a good starting point to understand how a Pi4J project is created, what libraries are needed, how you define them, how you define a LED object and a button object, digital input and digital output. So all these things are inside this minimal application. By the way, this big fan here, that's more show than really needed because the Raspberry Pi doesn't really get that hot. Now let's build something more complex and show you a bit more of what can be done with Raspberry Pi and with Java. And the sources of this application that I will show you are available on my GitHub account in the repository Vaadin examples. So there you can find the full project with some information about how to run it. The wiring is also linked, and it links back to the documentation which is available on several blog posts. I will be using a CrowPi. What is the main advantage of this CrowPi is that everything is already wired inside. So it's a little suitcase or a laptop design with a lot of components, buttons, several electronic components which are pre-wired. You just put a Raspberry Pi inside. Either you buy it with a Raspberry Pi or you use one that you already have. It has a screen, a touch screen. The second edition also has a keyboard, and it allows you to experiment. It comes with a lot of Python code because Raspberry Pi was originally designed to be a Python experimentation device, but yeah, it's a full Linux PC. So it means you can use anything you want on there, like for instance Java. Now, again, on the Pi4J website, you will find a lot of information about this CrowPi and what you can do, what's included, how you set it up, for instance, with IntelliJ to do remote development. And we had the luck that students from the Swiss FHNW University spent the project on creating Java examples for each component inside a CrowPi 1. So you see on this list, and again, this is a project shared on GitHub, that there are applications here for the buttons, for the buzzer, for the humidity, reading humidity and temperature, putting something on an LCD display. So they created example code, really well structured. So you have applications, you have components inside this project, and a lot of this can be reused. So they have constructors which use predefined, like for instance, the pin that is used for certain components. These are pre-configured for the CrowPi 1, but there are also constructors where you can overwrite these values if you use the same code in your experiment where you have other components or the wiring is different. So that's something you can easily reuse. Check something. Okay. So if you start this application in the terminal, you will get a menu and you can choose one of these, type in the number, and the demo application will do something like, for instance, put content on the LCD display and just run this one application and then terminate. For my experiment that I will show you, I've used Vaadin. I really love JavaFX to build user interfaces, desktop user interfaces. You can also use JavaFX for web-based application, but that's not so well known and you need some additional steps. But another approach which I really like is Vaadin. And Vaadin is, I always call it JavaFX for the browser because it has the same feeling. You create your application and your user interface in Java code. So as a Java developer, that's the thing you know. You don't need to mess with JavaScript. You can fine-tune CSS if you want, but they already have a very nice styling applied to all the components, so you can use it just as is. And they have this start.vaadin.com website where you can pre-configure your project. You can add screens, pages, you can style it, you can define colors, you can add components. And if you download it, you will get a full Maven project and you're just ready to open it in your IDE and hit run on the main method, and it will give you a local host, a running application in the browser that provides you with a user interface and a backend in Java, where you can, for instance, talk to a database or send messages across a messaging system. But of course, also can control electronics if you add the Pi4J libraries. And that's exactly what I've done. So in this demo, I've used a few components to be able to show you the different types of control of electronic components. Like the LED and the touch are digital output and inputs, the same things that I use in the minimal example. But there's also the LCD display and the 7-segment display. These are controlled to I2C, so one of these types of communication that you have with electronic components. Same for the LED matrix and the same for the buzzer. So these are different types of communication with an electronic component, all provided by the Pi4J library, which are part of this demo. And it allows you to learn a bit about the fundamentals of computers, which are ones and zeros. And that's something I drifted away from because I told you at the beginning, I did film school, so I'm not a trained software developer or a software engineer. So I learned a lot from experience and trying out. And that's the same thing when I did website development and created CSS. You need colors. So you want to define colors for your website. And we are used to this kind of hex values. So FF0000 is full red, and the second one is green, and the third one is blue. So that's something we know. But what do these values really mean? Do you still remember that? Did you learn that in school, or is it something that's just there and you use it with your experience? Now, actually, this also goes back to ones and zeros. And if you start experimenting with electronics, it's rather important that you understand a bit of this, because for some of these components, you really need the bits to define some values, and I will come back to that. So FF0000 is actually 8 times a 1 and then 16 times a 0. That's what comes out of this. This is how you represent that value in ones and zeros. So let's dive into the beginning of how this works, and we'll come back to how we use this. So FF is 8 ones, okay? How do you calculate this? Everything is based on the power of 2. So if we have 4 zeros, like in this case, then the total value is 0. If you have the lowest value is becoming a true, a 1, then it's 2 to the power of 0, and we start counting at 1. If we shift 1, then we are at the value of 2. Now, if we want to have a value of 3, we count 2 plus 1 is 3. And if we want a 4, then we move again. And a 5. So everything is based on shifting this 1 in the row and then calculating. Now, when I started at one of my previous jobs, we really needed to exchange data with ones and zeros. So this was really new to me. And actually, I found this little video which really shows you how this works. In case you've forgotten, you never learned this like me. And this seems like a very nice project to build in a weekend, I think. Or just watch the video. So this illustrates how the ones and the zeros are just shifting to get to a value of, for instance, 16. And so on, and so on, and so on. So this is how bits and bytes are used and hex values. Now, why is this important? And we come back to that little 7-segment display I showed you at the beginning, and how you control a display like that. Like, for instance, take the value 60. That's a hex value. It doesn't mean anything now, but if you look at the ones and zeros, then this is how this translates to bits. And it's important if we want to control a device like this. So it's called a 7-segment display because it has 1, 2, 3, 4, 5, 6, 7 segments to display a number or even a character, but it also has a dot, so it's 8 if you want to control all of this. Now, 8, that's the number of bits we have in 1 byte. So that means that we can define the state of this little display with 1 byte. We have enough with 8 bits, so we can control every segment of this display with one hex value. And that's where the 6D comes back. So 6D defines all the segments that are on a 7-segment display to show you the number 5. And for my book, I created this little JavaFX application that you can also find in one of my repositories, which shows you the relation between the bit value, the hex value, the number value, and how it looks like on a 7-segment display. And it becomes really fun if you use these hex values to control a display like this. Now, if you're not using a CrowPi, but using the components that you can find in an electronic starter kit, then you end up with an example like this. So you see this little segment display, there are some resistors, a lot of cables, and a chip. And what this chip actually does, it's the chip that is connected to the Raspberry Pi, and you see that there are only a few wires here. And these wires allow you to send one hex value to the chip, and then the chip will turn off these 8 segments on the display. So you see here the resistors and the cables going to this 7-segment display. So if we, from the Raspberry Pi, send 6D to this chip, it will put on the requested LED segments. Okay, let's look at a bit of the code of the application that I will show you. So I said that you can find it in the Vaadin examples in my repository. Now, this is the full Maven project that I will use for the demo, and it has different screens, and that's what you see here. So we are in the main layout of the application, and here you see all the navigation options that are provided. So you have a screen that gives you information about the Pi4J, about the system. Then we have a view for the LED control, for the buzzer, and so on and so on. So everything is controlled from here. And if you look at one of these pages, I can maybe show you this page. So this page that allows you to control the text on an LCD display for row 1 and row 2. If you go back to the sources, then you see that creating this user interface, this web page, can be done thanks to Vaadin in a Java class. So here you see that we have a button, and we can have a click listener attached to it, and this click listener will call the Pi4J service. We'll come back to that. And the Pi4J service will clear the LCD display. And then we can have a text field with a label row 1, and this is a text field where we can type in something. It has a maximum length of 16 characters because that's the limit, the physical limit of that little LCD display in the CrowPi. And then again, we have a button, and if we push this button, it will tell the Pi4J service to set on the LCD display in row 1 this text from this text field. So everything we see here is all the code we need to have a text field that the user can type in some text and then put it on the little display. And again for the second one. So you see, very, very, very minimal code to create a web page like this. There is some extra stuff here. There is also a listener that we can show what's happening in a data grid. But that's more for the sake of this demo than really needed for this application. Another view is the 7-segment view. So I can show you the device. So you see the device has 1, 2, 3, 4 now on it. If we go back to the page, and here we have drop downs. So this is a set of predefined values that can be set on the segment display, and we have them in drop downs. Where are we? Let's see. So we have 4 drop downs, combo boxes, and we have a 7-segment which is Can I click through this? Doop, doop, doop. I've never done this before in directly in GitHub, but I'll not go to that. And so on and so on. And again, we have a listener when the value changes to put it on the display. Okay. So the Pi4J service, you see, this is a Spring application. Vaadin uses Spring to create an application. So we have the same kind of structure that we are used to for a Spring application. So in the service, we have a Pi4J service, and this Pi4J service is initialized at startup of the application. So it will configure the Pi4J library, make sure that everything is loaded and prepared. And then again, for the demo, to make it easy to understand, everything is initialized in separate methods. Like for instance, if we want to initialize the LED, you may, or you should recognize this code from what I showed you earlier. So this makes a LED Java object that can later be controlled through the code. If we go to the LCD display, the LCD display is again a separate component that is easy to configure and to use inside this code. Now, if we go to, let's take, for instance, putting something on the LCD. Yeah, set the LCD display. So I showed you UI to allow the user to create a text and put it on the display. So here you see that it gives you a row and a text, and then putting it on the LCD display is just right line with the text and the row, and it puts it on the already configured LCD display. So you see, this is, in my opinion, very easy to understand Java code, because a lot of the complexity is already handled by the Pi4J library, and then some smart coding done by these students, which is available on the Pi4J project, can be used to control all this. Now, this is the running application. Let me first share another screen with you. One moment. Yes. Okay. So this is the Raspberry Pi where this is running on. I have a few terminals open to show you what's happening. So you see here that we have the logging of the application. While I was testing just before this talk started, I managed to get an error. It's still there. I need to look into it and see what happens. But it will also log what's happening, like for instance, putting something on a LED matrix or clearing the LED matrix. All this is logged here. I have a tunnel open because I will invite you to join my demo in a few minutes. And I have the performance of the application. So the Java application is running. It's a Spring application. We are running on a system, I think, with 2 gigabytes of memory. Yes, 2 gigabytes of memory and quad-core processor. So you see that not a lot is happening here. We have a lot of free resources. This board is capable of handling a lot more than what we are doing now. And okay, let's go back to the other screen. Okay, I will show you the CrowPi instead of me. Okay, so you see the CrowPi now, and I can just clear everything which is on these 7 segments, for instance, and then put something else on there. So you see that I can control everything from here, and things are happening on my electronic components. And this data grid here shows you what's happening, and it actually will show you the results. If several people would be doing the same thing at the same time, you would see stuff appearing here because other people are also interacting with this display. And again, in the logging, it shows you also the magic of bits and bytes. So 3F, for instance, is 7 ones. So you see it here. Everything for a 0 means that we have or six ones. So we have all the LEDs to form a 0. And I can clear it again. Now, this application gives you a lot more information. So it's also about which Raspberry Pi is used, which Java version is used. It should not surprise you that I'm using Azul Zulu version 19, but any version runs on it. So you can also use, of course, 21. It's 19 because I didn't update it yet. It also gives you some information about the system and how many people are detected and CPU usage, but this is experimental. I'm not so sure that this is all correct, but I gave my Java application not all of the available memory, of course, to keep something available for the system itself. So it's only using 15 megabytes of the foreseen 450. So remember, this is a Java application, Spring application, all the stuff that you know, but on a very cheap computer. I think this one is about 40 euros, I think. And we can also control the LCD display, and we can control the LED matrix. So we can put a heart on there or a cross or clear it. Okay. Let's try something. I have no idea how many people are in this session live at this moment because this will also be recorded. This will not work anymore once the recorded session is published, but I invite you to visit pi4j.ngrok.dev, and that should allow you to access my Raspberry Pi, which is behind me. And let's see. There are definitely some people connected now. And as you can see in the camera, someone is putting values on the 7-segment display. So that means that you can now interact with this device and see what's happening there. So I don't know if someone can put something on the 7. So I didn't do anything, but you see on my screen, this appeared. So I get info pushed back to my user interface from other users. So you see that this Vaden can handle a lot of logic behind the scenes and allow different people to control with one application, and then can also get updates. I don't know if you hear the buzzer through my microphone, but some people also discovered the buzzer. And the buzzer is another way of controlling electronics because it's using pulse width modulation, PWM, so to generate different tones. And again, I didn't do anything, but you see that the event of other people is being displayed in my screen. I have the impression that you will love this. I definitely do. And now I'm in doubt. Do I need to kill my application to stop the buzzer, or you stop it? But never mind. That's the side effect of experiment with electronics during a demo. Okay. We have some time left, which is great because maybe there are some questions. But I already want to invite you to see what's next. So I have this great book that I just leave the camera on the CrowPi for a moment. This book is, of course, still available on LeanPub. You can find it through webtechie.be. I'm not so active anymore on Twitter, but I'm on Mastodon on fujj.social. I write a lot about all this stuff, and you can find it if you search for the hashtag Java on Raspberry Pi. You can find a lot of this information on fujj.io and on pi4j.com. And yeah, I invite you to experiment, fail and learn. That's the only, failing is the only way that you can learn. And repeat. Experiment with electronics. It's really great. It allows you to learn a lot. That's what I did, both about Java bits, about electronics, but of course also about Linux, how a system like this works, how you set up a Raspberry Pi, how you can control it, how you can control it remotely. I hardly ever touch a Raspberry Pi itself or connect a keyboard. Everything is done through my PC. So you learn a lot about networking, about DevOps related stuff. So all that kind of knowledge is knowledge that you will gain from this kind of experiments, and have fun. That's the main message. If you start doing this kind of things, you will have a lot of fun. You will also get frustrated. That's definitely something which also will happen. You will probably destroy a few LEDs and resistors, and I killed a few of these 7-segment displays, but they are very cheap. So it's worth it if you break a few of them. Also, debugging then becomes a challenge and something you will learn from. Someone beeped again. Okay, that was my presentation. That was the story I wanted to share with you and I wanted to tell you. And I don't know if there are already questions, but we also have a discussion on the Pi4J website and GitHub. So that's something you can also join.
Thank you so much, sir, for that very interesting presentation. I was actually entertained with what you presented, especially the demo part. And I hope our participants here have really
They,
also geeked out with you in this presentation. So
they still have fun. It beeps from time to time still.
I hear it. I hear it too, sir. So I think we have one question here from
Mhm.
our audience.
Arduino, yeah.
From Mark Stephen Clement of Orange and Bronze. I had experience with Arduino boards before.
Yeah, it's shortage.
Ignoring the Raspberry Pi shortages, would it be viable to replace Arduino boards with Pis, or will there be benefits on having Arduinos alongside Pis?
Um, they have different use cases. So an Arduino is a microcontroller. That means you cannot run Linux or Java on it. So for the drum boot of my son, I use both. I have a Raspberry Pi with the JavaFX user interface, and I have an Arduino to control LED strips. LED strips is something tricky to do from software, from Java. We also have a solution now, which is also, of course, documented on pi4j.com. So it's possible to do that with there are a few things to consider. What is your use case? What is your budget? Because an Arduino is still cheaper. But as a Java developer, you want to do this kind of stuff, you'll need a Raspberry Pi. So you cannot do that with an Arduino. There are different use cases. I do love Arduino. I've used it a lot also for experiments, but this kind of things that I now showed you are not possible with an Arduino. And you need a full Raspberry Pi to do that.
Understood. All right. We have another question here from Stephanie May Caparida, a faculty in
Mm.
MSU Iligan. Interesting. Is there a possibility that we can do data analytics with the data that we gather remotely, especially when we use sensors with
Mhm.
Pi4J?
Yeah. What I have done in a few of my examples is use a message bus, MQTT. So that's one way that you can send the data from your sensors to another system. But you can, of course, also install a database on your Raspberry Pi. That's also something a lot of people do. So, can you do data collection on a database? For sure. MySQL, Postgres, anything can be installed. Uh, do you want to use messaging? MQTT can be installed. Mosquito is described in my book. Is something you can install on the Raspberry Pi. You can use Grafana. You can use Prometheus. All that kind of stuff can be either part of your Java application or can be installed separately on the Raspberry Pi. Can run on it. And actually, get back to the Arduino. You can, for instance, Arduino ESP32, which are very cheap devices to put anywhere in your house with a sensor. And you could have one Raspberry Pi with a database which is collecting this information. So you can have all these different sensors sending data to a Raspberry Pi that you use as your own home server, where you store this data in either a database or in your application or in some other form, and use that for analytics. So Grafana is definitely something which again can be used on the Raspberry Pi. Someone found the.
He's really enjoying the
I challenge someone who can really play a song on it, because that's a hard one.
oh,
Do-
challenge was posed.
yeah. I heard something. So someone found something.
Wow. Wow.
Yeah.
Yeah, I all right. But actually, Stephanie followed it up the question earlier with, I mean, display data in a graphical way with a statistical tool. So,
Grafana is sure a way to do that.
all right.
Yeah.
All right. We have another question here from Pen Abrea of Resource Solutions. Given the popularity of AI, are there any benefits to learning the Raspberry API?
Yes. There's one problem with a lot of language models, that they are a bit too big. Then it depends on what type of Raspberry Pi you have, but there are Raspberry Pis with 8 gigabytes of memory. So that's something where you can do that. I invite people to check LangChain4J. So LangChain is a well-known library to interact with, for instance, ChatGPT. But there is now LangChain4J for Java, for that means. So LangChain4J allows you to interact with machine learning, ChatGPT, OpenAI, that kind of stuff. So again, if you need a server where you want to run machine learning experiments, Raspberry Pi can be a great way to do that. And the main thing about using the Raspberry Pi is it's a full Linux computer. So if you are on Windows or on Mac and you want to experiment with Linux, you can, of course, install a virtual machine on your PC, but you can have a very cheap Raspberry Pi and do stuff which is Linux specific on it. And another buzz thing, buzz, it's not even a buzz anymore, is Kubernetes and clusters. So Raspberry Pis are also used, if you now with the chip shortage being solved, that you can do that again, is buy 3 or 4 Raspberry Pis and use them as 3 or 4 Linux servers and create your own clusters. You can have Minikube, I think, or some forms of Kubernetes are available to run on a cluster of Raspberry Pis. So instead of hiring very expensive computers in the cloud from Amazon or whoever, you can just run it locally on your Raspberry Pis.
All right.
Oh, you
Thank you
have a
so much.
visitor.
Yes, my dog. I'm so sorry, but my dog
No problem.
is
Normally my dog is sleeping there, but she's not here
my,
now.
my dog is trying to listen into your to the sounds of the buzzer. So that's why he's been bugging me here beside me. So I think that's all our questions this afternoon.
Thanks for
I
the
really
questions.
hope, yes, I really hope all your questions are answered. And if you have any more further questions for Sir Frank here, I think you can feel free to chat with our speaker here on AirMeet. Or Sir, I think you've given your socials earlier so they can
Yes.
connect with you directly. So and if I'm just so proud to be the moderator of this session because everyone is just so geeked out and they I think everyone was throwing on the wow and the cool emojis all throughout the session. So I
Yeah, I saw them
can
passing. Yeah, that's
assume that
great.
everyone did really enjoy your session, sir. So thank you so much once again, Sir Frank. That's all the time we have for this session. Again,
Thank
let's
you.
thank Sir Frank Vilport by
Thank
showering
you.
him with
Thank you for.
emojis. I'll give you a round of applause for everyone.
Thank
All
you.
right. Thank you so much again, Sir Frank, and we hope to see you again soon and to hear from you again soon. So, thank you everyone for joining this session, and you may now exit this session and join the next one. Thank you. Have a good
Thank
day.
you. Bye.